color do you think my eyes are? A bit hard to tell in this light, isn't it? Wow. Let's discuss and have a closer look. Tingles with flyby. Daily ASMR videos. Hello, my tinglings. Well, I'm sure you can see the title of this video. Be talking about what color are my eyes. So this is actually a very difficult question for me to answer when I was a kid, or any time I have to fill it out for driver's license or anything like that. But before we get into my eye color specifically, just want to talk a little bit about eye color in general. So I have our trusty Wikipedia over here to help us out. So eye color is a polygenic phenotypic character. So that means basically that there are multiple genes that code for eye color. So it's not just a single gene and you either have it or you don't. There's lots of genes kind of working together which produce the eye color. Excuse me. So there are two factors that determine eye color. There's the pigmentation of the eye iris. So melanin is the main pigment in eyes, and so at the back of the iris there will be a certain amount of pigment there. So very, very dark brown eyes, they have a lot of pigment, and that's what makes them appear brown. It also, though, depends on the frequency dependence of the scattering of light and by the turbid medium in the stroma of the iris, which basically means that in different lighting conditions, eye color can actually look different, which is partially probably what's caused a bit of an issue for me as a child, because trying to stick with the traditional eye colors that I've heard of, I would say sometimes my eyes look blue, sometimes they look green, and sometimes they look gray. And those are the kind of colors I would usually say. So, for example, if I wear a very bright blue top, then the blue in my eyes really comes out and they can look very blue. But a lot of times they can look green. And I know that sometimes they look gray, but I never actually figured out when they look gray. But I do know as a kid, sometimes I would look at them like, oh, they look kind of gray. So when I was a kid, I used to say that I had rainbow eyes, but I actually know what type of eyes I have now, but I'm not going to spoil it. So, excuse me. So the melanin in the eyes is on your iris pigment. Don't know if any of you, when I was in 7th grade, we dissected a cow eye. And so it's at the back, you have this really gorgeous coloring, actually. But that's where your iris is. The cellular density. So the appearance of blue and green eyes, as well as hazel eyes, result from Tingledom scattering of light. So Rayleigh scattering is the name for the diffusion of light, which causes the sky to look blue. basically because there's atmosphere around the Earth, and as the light comes through, because it gets scattered, it then looks blue rather than just like white light, which is what the sun actually is giving us, white light. So neither blue nor green pigments are ever present in the human iris or ocular fluid. So the pigments in the eye are not actually blue or green. It's all the same pigments, but it's basically different amounts of pigment as far as I understand it. So I think blue is the least amount, and then, well, brown is the most. I think it's like green next, and then hazel, something like that. So eye color is structural color and depends on lighting conditions. So that's why I would sometimes perhaps see my eyes as different colors. There's also a second factor for that, which I will get into. Now let's get into... So there are there's multiple genes, but there's 4 genes that are definitely known to be associated with eye color. There's the Oca2 gene. This is associated with melanin producing cells and very central importance for eye color. We also have HERC2 that affects the function of OCA2, the last one we were talking about, which has a specific mutation strongly linked to blue eyes. So there's probably something going on there in my eyes. And then SLC24A4 is associated with differences between blue and green eyes. So this is probably important in my eyes. And TYR, that has a similar function. So blue eyes with a brown spot, green eyes, and gray eyes are all caused by an entirely different part of the genome. So we have all these different parts of the genome that are coming together to form the eye color that we see before us. Of course, because of my ring light, you're seeing a nice ring, I can't actually see my true eye color, but we'll get to that. Okay, so there is a chart for eye color, and it's called the Martin scale. The numbering is reversed in scale. So basically, the lightest eyes have the highest numbers. So you have 16, which is a pure light blue. So probably like the lightest eyes that you would see. 15 is a gray. Light mixed is 14 to 12. So you have 14 is very light mixed blue. So blue with gray or green with gray. So just very, very light pigmentation. And then 13 to 12 is light or very light mixed with a small admixture of brown. Then 11 to 7 are mixed eyes. They're a mixture of light eyes, blue, gray, or green, with brown and light and brown, when light and brown appearances at the same level. Okay, so if you have kind of a combination between, not necessarily saying that you have, it's just if your eyes get a bit darker, that means you have more brown melanin. So if you've ever seen people have really piercing light eyes, those would be the really light ones. And darker eyes may still appear blue or green, but they just look a bit darker. So that means they have more melanin. Then we have 6 to 5, which is brown with a small admixture of light. So if you see people with kind of light brown eyes, that's probably the color, say like my dad's are probably a little darker, but my love has fairly light eyes, as does my best friend. They both have brown eyes, but a bit lighter. And then dark is 4 to 1, so these are very dark brown eyes. So that's our scale. What's really interesting then, getting into what is my actual eye color. So if you look at my eye color right now, it probably looks fairly blue. And that's because there's a ring over a very key component. I'll try and come a little bit closer, but it still won't show very much. So there's a rare genetic mutation, shall we say, called heterochromia, and that is something that's playing around in my eyes. Heterochromia means having more than one color in your eye. So if we think about, and there's a few different types. So you have a complete heterochromia. So the word heterochromia, chromia is a word for color. It's Latin, I think, chroma. So chromia, that's for color, and then hetero meaning, if we know homo means the same, and hetero means different. So heterochromia means different colored eyes, basically. Pretty simple explanation for a kind of jargony term. So heterochromia means 2 colors of eye. So if you know, who's a good example? If you watched Dr. Quinn, Medicine Woman, what's her name? Jane Seymour. She actually has 2 different colors of eyes. There's a few other actresses. Mila Kunis apparently has them, but hers are not very distinct. Anyway, there's a few people who have heterochromia. And they're a complete heterochromia, which means one eye's one color, one's another. And it's the most striking when you see somebody, say, with a brown eye and a blue eye. So that's quite rare. There's also partial heterochromia, which means within the same eye you have one part that's one color, one that's another. This is what David Bowie has. He doesn't have complete heterochromia. He actually has the different colors within the same eye, and it's just kind of portioned off, almost like a pie piece. And then there's a third type, and it's called central heterochromia. So central heterochromia means that you have one color on the outside of the eye, and then another color in a ring around the center of your eye. And that is what my eyes are. Now, it was interesting when I was looking up about central heterochromia. The article I was reading saying, heterochromia is rare genetic mutation, and they think only about 200,000 people have it in the U.S. But they also said that they don't see it being hereditary. They think it's just kind of, a mutation that happens. But I don't think that's true at all. Because when I was reading about heterochromia, I was thinking about my sister's eyes, and I thought, she has central heterochromia as well. Her eyes don't look at all like mine. She has green eyes with a brown circle around them, but that is still a heterochromia. It's different from, so hazel eyes are generally considered a kind of brown and greenish eye, but for that sort of eye, it's pretty, if you look up different eyes, for a hazel eye, it's a pretty, like, smooth transition. Whereas with central heterochromia, it's a very distinct ring, so you can kind of tell one to the next. It's not just a gradient going from one to the other. But the other reason I didn't think it was not, like, hereditary is because I remember when I was at I don't remember if it was my grandma or my granddad's funeral. I think it was my grandpa's funeral. But I remember, because I've always kind of been curious, and so my eyes are basically, we have blue pigment with a yellow ring around. It's kind of a yellowish brownish, but it's very light yellowish brownish, so I always call it kind of yellow, which makes sense why it would look green in some lights, because that yellow tinge is really coming out and coloring the rest. Whereas, you know, like right now, if you're looking at me and I've got this ring covering that yellow portion, then my eyes are going to look much more blue. So I was at my grandpa's funeral, and I've always, you know, I kind of realized I have these blue eyes with kind of a yellow ring. And so I've just always kind of had my eyes blue or green, just whatever my mood is, you know. But I was looking around and I noticed, I've known that my mom has very similar eyes to me. And then I was looking around and I saw all these other, I think I saw like 2 or 3 other people with my exact same eyes. So I was like, this has got to be hereditary. So when I was researching for this video, I also made a post on so we have this group for my grandpa, all his descendants, well, his family and their descendants. So I put a post in there asking who else thinks they have central heterochromia. And I think we had 8 or 9 people who said that they have it. Some with my coloring, some had brown with a yellow ring, some green with a yellow ring, and then some like my sister that has green with a brown ring. So there must be some sort of hereditary component that promotes that color pattern, where the color pattern then changes based on other genetic factors, but that must be hereditary. So I knew it had to be because my mom has the same eyes, first of all. But so I thought it was funny that they said that it wasn't. But yeah. So yeah, I have central heterochromia eyes. They're blue with a yellow circle. That is the color of my eyes. So if you've ever wondered